Hi all and welcome to Being a Physicist. Right, so the success criteria. After you've watched this wee PowerPoint, you should be able to state that the human range of hearing is between 20 and 20,000 Hz. You should be able to state that sounds above the human range of hearing are called ultrasounds. So that's sounds that we can't hear. And you should be able to describe a medical and a non-medical use for ultrasound, which is sounds that we can't hear. Now, sound needs particles to travel. If there's no particles, sound will not be able to travel. The more particles you have, the better the sound can travel. So for example, solid surfaces where there are more particles, sound travels very well compared to, for example, gas where there's less particles, it doesn't travel quite as well. And that's why if you put your head on a desk or your table and tap it, you can hear the sound much louder because sound travels much better the more particles there are. Now, animals, including us, can only hear a certain range of sounds. Low-pitched sounds are called low frequency. And high-pitched sounds are called high frequency. Now, frequency, what is that? Frequency is how many waves are produced in 1 second. That's the frequency, how many waves are produced in 1 second. So, 1 second, that would be high frequency. 1 second, that would be low frequency. So sounds can be low pitched, a low frequency. So in the same amount of time, there are less waves produced. Or sounds can be high pitched, a high frequency. So we can see in the same amount of time, we have more waves produced. Now, how is frequency measured? Well, it's measured in hertz or kilohertz, which is 1,000 hertz. So a low frequency might be 20 hertz. A higher frequency might be 2 kilohertz, which is 2,000 hertz. Or they can have an increasing frequency. Here, the frequency ranges between 20 Hz and 20 kHz. So 20 Hz and 20,000 Hz. And eventually, we can't hear the sounds because its frequency is too high. So that is called ultrasound, and that is frequencies above the highest that we can hear. For example, greater than 20,000 Hz. So let's consider non-medical uses for ultrasound. Well, the first one is they can be used to find the depth of the sea or to identify fish that are under the water. So for example, the ultrasound waves, and remember these are frequencies above the highest that we can hear, are sent down from a transmitter on the ship. The waves then hit the seabed and bounce back up as if an echo. The reflected waves return to the ship where they are picked up by a receiver. And we can then calculate the distance from the boat to the seabed using the formula. Distance equals the speed of the ultrasound times time. So that is speed of sound in water, which we know, and the time it takes for the waves to return to the surface. And if we have these two factors, we can work out the distance from the ship to the seabed. Ultrasound or sonar can also be used to locate fish. For example, here we have this shark under the water. So the ultrasound waves are sent down from our transmitter. On the ship, the waves hit the shark and reflect from it as an echo, and the reflected waves return to the ship where they are picked up by the receiver. And we can calculate the distance from the boat to the shark using the formula. Distance equals speed times time. We know the speed of sound in water, and we can measure the time taken for the sound waves to return, the ultrasound waves to return, and we can calculate the distance from the ship to the shark. A medical use for ultrasound is to scan unborn babies. So here we have the monitor where we can see an image, and the transceiver, and the patient. So how does this work? The ultrasound waves travel into the womb from the scanner and reflect from the baby. So they bounce off the baby and return, creating an image. Now, ultrasounds are safer than using X-rays as they are not a form of harmful radiation. So let's see how successful we've been in this lesson. Can you state that the human range of hearing is between 20 and 20,000 Hertz? Can we state that sounds above the human hearing range are called ultrasounds? That sounds greater than 20,000 Hertz. Can you describe a medical and a non-medical use for ultrasounds? So let's do some revision. What is a measure of how many times an object vibrates per second, or the number of waves produced in a second? Well, that would be frequency. Frequency is a measure of how many waves vibrations are made each second. What is the unit used to measure frequency? Well, that would be hertz. What is the normal range of hearing for a human being? Between 20 and 20,000 Hertz. What are sounds above 20,000 Hertz called? Ultrasound. So give an example of a medical use of ultrasound. Remember, we use it to scan unborn babies. The ultrasound waves reflect off the baby's body and create an image. Give a non-medical use of ultrasound. Sonar, used to find objects under the sea. So let's try these questions again. What is a measure of how many times an object vibrates per second, or the number of waves produced per second? Frequency. What is the unit used to measure frequency? Hertz. What is the normal range of hearing for a human being? Between 20 and 20,000 Hertz. What are sounds above 20,000 Hertz called? Ultrasound. Give an example of a medical use of ultrasound. Scanning unborn babies, the ultrasound waves bounce off the baby, reflect off the baby and create an image. And remember, that's safer than using X-rays. Give a non-medical use of ultrasound. Sonar, used to find objects under the sea. Your final task is research. Try to find out another use of ultrasound.